How's it going, everybody? It's almost midnight on April 9th. I'm trying to get all these videos done for next week. So hopefully you guys are dead and not trying to finish the assignment that's due tonight. Yeah, hope everybody's doing all right. Hope everybody's staying healthy, staying in. Hashtag flatten the curve. All right. Okay, so this is a section 8.5 day 1. I am so disappointed because if we were to do this in class, there's an awesome group test that I was going to give you, and it's so good. It's like one of my favorites of the year. Like there's some really good problems in it. I'm like, oh man, bummer. You guys are totally missing out. Totally missing out. But nonetheless, we're in our circumstances. We can't change that, right? What's that Teddy Roosevelt quote? Do what you can with what you have and where you are, something like that. It's a really good quote. Look it up. All right. So let's get started, shall we? So section 8.5. Now this, I've probably already said something about it in the intro video for the week, but section 8.5 is split up into 2 days. Section 8.5 day 1 is solving rational equations. Section 8.5 day 2 is solving rational inequalities. And then on Friday, we're going to have a quiz over just sections 8.4 and 8.5. We decided not to have like big chapter tests in this just because with things being so spread out and drawn out, like if we try to go all the way back to section 8.1 to take a test over all of chapter 8, it would be like going back to all like the inverse and direct variation and combined variation stuff. No, thank you. No. So we're going to try to chunk it in as many little quizzes as we can rather than big tests. That's our goal. So we're just going to be doing section 8.4 and 8.5 on that quiz that's on Friday. All right, so let's get to it. I'm going to take my face off. Yeah. All right, here we go. Solving rational equations. Now, think all the way back to before we even started this chapter. We did that whole day on, or not day, 2 days on working with fractions, right? And that second day we had to solve in a unique way to solve these fraction equations. Like if I had, 3/4 x plus, and I'm just making this up, this is not going to turn out really nicely, 2 thirds is equal to 1/12. We'll just say that. Okay, I have no idea how this is going to work out. And I said, okay, what would happen if we could we subtract by 2/3 and then divide by 3/4? Of course we could. But what would happen if we multiplied through by the LCD? Well, the LCD in this case, think about all factors being represented. Well, my LCD, if this is the prime factors are 2 and 2, and this is 2 times 2 times 3. So my LCD is 2 times 2 times 3, right? It's, in other words, 12. So what we have to do here is take a look and see, okay, where are all factors represented? Okay, well, 12. 12 is where all factors are represented, right? So we would multiply through by that whole equation by the LCD, which generates this really nice equation. Well, we'll cross reduce here. 12, 4, that would be a 3 coming out, right? So 3 times 3 would be 9x, right? That would be a 36 over 4, right? Divided out, 9. Plus, and then I would multiply in here. So that would be a 24 over 3 or an 8, right? Or cross reduce there. 12 over 3 would be a 4. 4 times 2 is 8. Is equal to, well, the whole thing would cancel out here. So just be a 1. And then it creates this really nice equation, 9x plus 8 equals 1, which you can solve really easily. So this idea of multiplying through by the LCD was kind of foreign to us. So that's why we taught it to you as just using it with these numerical fractions, because now it's going to come into play. A rational equation is just an equation that contains one or more rational expressions. And we've worked with rational expressions. They just have numerators and denominators that have polynomials in them. Now, to solve them, we're going to start multiplying through by the LCD. exactly how we did it with our numbers. Okay, that step eliminates the denominators. That's why it's nice. Okay, all right. So let's just go for it. Well, this first one has quite an easy LCD, right? There's only one denominator. My LCD, and I would write it off here, right over here to the right. My LCD is just x, right? So what I'm going to do is I'm going to multiply this entire thing through by x. What does this generate for me? Well, that's an x squared. X times x is x squared. What does this generate for me? Well, that will cancel. That will cross cancel, just leaving an 18. What will this give me? Okay, well, that's a 3x. Let's write a negative x. So I got an x squared. I'll bring this over. Minus 3x minus 18 equals 0. Factor that up. X minus 6, x plus 3 equals 0. So x equals 6 or x equals -3. Those are two solutions there where this would work. It's always a good idea to check your answer where need be. Let's see. Would this give me a true answer? Let's get 6. 6 minus 18 over 6, is that 3? 6 minus 3, is that 3? That checks out. We get a -3 minus 18 over -3. Is that 3? -3 plus 6 checks out, right? Okay, and you're going to see why I check answers here in a second, but I get two solutions there. This rational expression generates two solutions. Okay, let's keep it rolling. Okay, well, remember that the LCD, first off, we must have all denominators factored down. Okay, well, that's easy in that case. What's the denominator here? Okay, so this factor of 3 needs to be represented. What else? Where's the other denominator? Right here. So this is x. So x needs to be represented. So my LCD is 3x. So that means I multiply through my entire equation by 3x. Now, when I do that here, that 3 is going to cancel out, leaving me just the x to multiply in. So 10x. Here, the x is going to cancel out, so just leaving me the 3 to multiply in. 12. Here, nothing is going to cancel. 6x. That's quite an easy equation. 4x equals 12, so x equals 3. Plug it back in to make sure. 10 thirds, is that the case, is equal to 4 thirds plus 2? Yeah, 10 thirds. Putting that into thirds, that's 6 thirds, or 10 thirds altogether. So that does check out. X is 3. So that one only generates one solution. Okay, now, you saw me checking my answer, and then you may be thinking, like, well, why? That's silly. Why are you checking your answer? Obviously, it's going to come out to be a solution. Not always. An extraneous solution is just basically a solution that, using our methods of solving the equation, generates an extra solution, right? An extraneous extra solution, something that's not part of your answer. That's a solution to the equation that we came up with, but not necessarily an answer to our problem, okay? So it's always a really good idea to check your answers, and you'll see here why in a second. Okay, so take a look at this one. What's my LCD here? Well, the first thing that I need to do is factor down my left side. So it's 16 over x minus 4, x plus 4. Okay, so we look at our two denominators. My two denominators, well, on this side, both factors need to be represented. So I have an x minus 4 and an x plus 4, right? Those both have to be up there. Okay, so this denominator needs to be represented as well. It already is with this x minus 4 there. So my LCD is an x minus 4, x plus 4. So I'll multiply this entire thing through by an x minus 4, x plus 4. Now, the entire thing cancels when I multiply it in here, so I'm just leaving a 16. Over here, only the x minus 4 would cancel out, leaving just the x plus 4 to multiply into that 2. So 2 times x plus 4. All right, so divide over the 2. 8 equals x plus 4. You could distribute in if you really wanted to. You'd get 4 either way. Okay, now, why should I check my answer? Because we know with all of this rational expression stuff, there are things that x cannot be. What can x not be? X can't be plus or minus 4. Did x come out to be one of those? Yes. No solutions. Okay? That's my answer there. No solutions. So plug it back in. What's happening here? 16 over 4 squared minus 16 is equal to 2 over 4 minus 4. We're getting a 16 over 0 is equal to 2 over 0. Yeah, divide by 0, error. Okay, there's no solution there. Okay, let's take a look at this one. Now, the nice thing about this one is that all parts are factored down. So my LCD here, well, here's my x minus 8 needs to be represented. Minus. My 2 needs to be represented. And then an x minus 8. Well, it's already there. Okay, so there's my LCD, a 2 quantity x minus 8. Okay, why'd the minus not come through again? All right, now when I multiply in here, that x minus 8 will cancel, leaving me just a 2. So 4x minus 10. Here, the 2 is going to cancel, leaving me an x minus 8 times x, or x squared minus 8x. Here, the x minus 8s will cancel, leaving me just a 2 to multiply in, or 22. Okay, so let's put it into standard form all on the left side. So x squared minus 4x, and then we have a negative 10 and then a minus 22, so negative 32 is equal to 0. Okay. All I did was reorder. X squared, the 4 and the negative 8 give me the negative 4, the negative 10 and the minus 22 coming over to the left to give me negative 32. All right, so factor that down. I get an x minus 8 and an x plus 4 equals 0. So x equals 8 or x equals negative 4. However, can x equal 8? No, x cannot equal 8 because of this here and here. Okay, x can't equal 8. That's the only thing x can equal. Okay, so that means my other solution is still okay. This gets thrown out. Why? Because x could not equal 8. The only solution to this equation is 4. Oh, excuse me, negative 4. Okay. All right. Oh, this is such a bummer. I love doing this problem in class. It's a bear of a problem, but I love doing it because it's like so much fun. But again, well, do with what you can, where you are, what you have, whatever that is. All right, so on a river, a kayaker travels 5 meters upstream and 5 meters down. 5 miles upstream and 5 miles downstream in a total of 6 hours. In still water, the kayaker can travel at an average speed of 3 miles per hour. Based on this information, what is the average speed of the current of the river? So we're looking for the current, right? I'm going to call that current C, round to the nearest tenth. Okay, so what we want to do here is we want to figure out what the current is. Now, we know the standard rate formula. Rate is equal to, if you think about anything, miles per hour, right? It's meters per second. It's always distance over time, right? So we have these three variables: rate, distance, and time. Okay, now let's make ourselves a little chart here. Let's make an upstream chart and a downstream chart side, right? And let's identify all three of these for this, okay? Okay, what's my rate going upstream? Well, if I'm going upstream, the current, my current is working against me, right? If I'm trying to paddle and I'm moving upstream, the current is going to be pushing against me, right? I can travel 3 miles per hour, but it's going to be minus whatever the current is because it's going to be working against me. It's going to be slowing me down. Going downstream, that's going to be helping me, 3 plus C, right? Because I've got my 3 miles per hour plus whatever the current is pushing me at. Okay, my distance here, well, my distance is 5 miles, right? 5 miles. And then time. Okay. So that means my time is a total of 6 hours altogether. Oh, okay. So if I know that the times added together equals 6, ooh, this is kind of interesting here. What I can do is say whatever the time is equal to, I can say, well, what is the time equal to for the upstream? Well, manipulate this equation a little bit. If I manipulate that equation, multiply the t and then divide by r, time is equal to distance divided by rate, right? Distance divided by rate. So my time on this side is really, well, distance divided by rate, 5 over 3 minus c. Same thing here. But in this case, going downstream, the rate is, so distance is the same, 5 over 3 plus c, right? Now, all together, it's 6. So the time all together, upstream and downstream, is 6. So I'm going to erase away this t right here, right at 6, and say, okay, upstream, downstream. And we have this nice, oops, 3 minus 5, when I get that 5. We have this nice equation that we can solve. Okay, what's my LCD? My LCD is a 3 minus c, 3 plus c, right? This is all factored down, so 3 minus c is my factor from my left side. 3 plus c is the factor to my right side. Okay, so on the left side, this gets me 6 times 3 minus c, 3 plus c. You know, all I'm doing here is just multiplying in 3 minus c, 3 plus c. You know, nothing cancels here. What cancels here? The 3 minus c will cancel, leaving us just a 3 plus c. What cancels here? The 3 plus c cancels, so the 3 minus c gets multiplied in. Okay, so let's multiply it out. I'm going to multiply those two together. 6 is equal to, so it's the difference of squares. 9, because first is 9. 3 times 3 is 9. Inners and outers will cancel. Negative 3c and a plus 3c will cancel out. So minus c squared is equal to 15 plus 5c plus 15 minus 5c. Ooh, fancy. Okay, so we get a 54 minus 6c squared is equal to 30. Subtract the 54 over to the other side. I get negative 6c is equal to negative 24. Divide by negative 6, 4. So c, oops, I almost wrote an x. C is plus or minus 2, but we obviously know that, you know, upstream, downstream, it can't go negative, right? It's always positive. So 2 miles per hour. 2 miles per hour. That's our current. Ooh, that's a fun problem, folks. That's a fun problem. All right. Well, hopefully we're all having a good day so far, and I'll see you when I see you. Later, people.